this session we will try to understand how pod will be created, how it gets IP address and POS container. So before that, in the previous session we have learned the CRI architecture, that Kubelet is talking to Docker shim, Docker daemon and containerd and run. See, this is a before Kubernetes 1.24. After Kubernetes 1.4 onwards, this is got removed and there is a CRI plugin as introduced, which will be talking to various container runtimes, followed by shim API, and which is followed by the various types of containers, right? And also we have learned in the previous session about the containerd architecture, right, which is, and also we learned the CTR tool as well, right? So before going to the today's topic, so we need to understand what is a networking model. Let's recap that. So Kubernetes networking model point of view, within a pod, container to contain, a communication should happen by using its local host. Second is, if two different pods within the cluster or within the node or within the different nodes, it should communicate by using IP address. And also Kubernetes pod to service, service to pod, vice versa, the communication should happen within the cluster. That's what the Kubernetes networking is telling. And also any external component also should be able to talk to the Kubernetes service, which is ingress, etc. And also Kubernetes networking model is saying that there is a shared namespace. Since these containers are Linux based, so these containers should share a network namespace. This is the word, the very in short about the networking model. And go to the Kubernetes official documentation, there is a details are available here, right? And the next, in order to implement a Kubernetes networking model, Kubernetes introduced a CNI, which is container network interface, which is nothing but it's a common set of standards, specification, libraries, etc., which is managed by the CCNF, right? And so CNI is basically a common specs for writing a CNI plugins. So why the CNI plugins? To configure a network interface. Why means because containers are Linux based. In Linux containers we need a basically networking interface. That's what the CNI will solve. And CNI who will use? CNI is used by container runtime, such as a Kubernetes or Pad1, crio. There are many more CNI supported. And if it is not supported, yes, there are some plugins are available like a Calico, Cilium, etc. There are many more plugins, and those plugin information is available here like a ACI, Arantera, AWS VPC, Azure CNI, Calico, Cilium, and etc. There are many more CNI plugins are available. So all the given plugins are following, including the VNet, until so all are following this particular standard. So how the CNI works? So let's say Kube API server is wanted to talk to a particular node. So if we take any node, basically node will have a host network namespace, right? And Kube API server will talk to Kubelet. Obviously the Kube API server is the first point of contact is this guy. Kubelet will talk to CRI plugin. We have learned in the previous session, right? Means the one is a containerd is a one of the plugin, right? And this containerd will go and create a pod network namespace, and then also CRI will trigger the CNI. This CNI will take care of a networking solution, such as linking the pod network namespace and host network namespace, adding a routes, etc., etc. So this CNI job is to take care of the networking solutions. CRI job is to take care of the container specific solutions, and we'll see further. So, and what exactly the CNI does, right? As we said, so CNI is basically take care of the connecting pods into the network, right? See here in the pod network, so pod will be created here. So how the pod will communicate to this particular network and API server, how pod is communicate with other pod, etc. And also CNI, how it will take care? It will take care of IP address management. So today's subject line is how the IP address will be assigned, right? That is a part of a CNI job. And what the CNI will does is CNI will insert a network interface between the container and as well as a network namespace. So as what the CNI will do is make sure every pod will get a own IP address. That's what the networking model is saying. And also the CNI will does an isolation, like one container you create that is completely isolated unit, right? And by using network policies you can completely isolate. There is a video on the network policies as well, right? So these pods are basically like virtual machines in its own namespace. So like for example, I have a 100 GB or 200 TB of a computer. There you can create some hundreds of virtual machines, but here pods are a very lightweight virtual machines which runs in own Linux namespace, right? Now so far we have seen about the CRI and CNI and how the Kubelet-CRI-CNI network communication will happen. First, this is a master node and there are the two worker nodes. Let's consider in the master nodes, of course, obviously a Kube API server, and also I will install a CNI plugin whenever I provisioning, right? That we learned in a CKA, right? And you install a CNI in master node and worker node 1, worker node 2, right? Now every node will have its own host network namespace, host, right? This is a host, this is a host. Now, and these two multiple host network namespaces are connected by using CNI, which is by overlay network, the CNI plugin. So right, one example is Calico I am using, right, which uses a BGP and Felix. So each individual CNI plugin uses individual technology, right? So now Kube API server will talk to Kubelet. This Kubelet will trigger a CRI and CRI will create a pod network namespace with the C group and as well as a namespace. Say, let's say you are creating one Nginx pod. So Nginx pod will be coming from Kube API server to Kubelet, Kubelet to CRI. CRI plugin means like a containerd. Containerd runtime will take care of this creating. This is number one. Number two, CRI plugin also invokes CNI plugin which is installed during the cluster setup. This CNI plugin will creates a network to this independently created pod network namespace and creates a with pair, virtual Ethernet pair between host and as well as the pod network namespace. By using this, both the ends ETH0 and the pair is called ETH pair, right? And also it will tells the host network that there is a route to be added. So it will issue an add command that, hey host, please consider this particular network, and also it will add one route entry here as well. So this CNI job is to take care of the networking only. Then after that, pod kubectl run -- image equal to nginx, so that nginx will be created here in the pod network namespace. The pod will be created before the pod, a POS container will be created, then your nginx pod will be created by the CRI plugin which is containerd. Now node IP address management, which is NodeIPAM and podCIDR. So in the CKA we have learned that whenever you are provisioning a new Kubernetes cluster, so we will be issuing a kubeadm init command and pass the API server advertising address and as well as a pod network CIDR, which is like a how many number of pods I wanted to give a capacity, as simple as that. So 100.64.0.0.16 is nothing but if you go to the subnet calculator, right, 100.64.16 which is 65,000 plus IPs, right? So and whenever you do that, then this kubeadm system will provision a Kubernetes cluster and as well as and a kube controller manager also will be created and which will populate the same value which we given, and controllers will give as a star, right? So here let's go to an example. there is a Kubernetes cluster which I have provisioned by using this vagrant, and this is the my 2-node Kubernetes cluster, one master and one worker node, right, and which is running in a containerd, etc., right. And kubectl get pods, right. If I say that, so it's a Calico network CNI I have installed, and whatever is in the worker node 1, which is have a IP 100.64 something, only in the worker node 1 100.64, right. Now here the kube controller manager will have a cluster CIDR is populated as this value which given during, and controllers are a star. So now kubectl describe pod this kube controller manager. If I go there, right, so if you notice cluster CIDR is this one. So this cluster CIDR 100.64./16, which is 65,000 IPs, will be served for the number of nodes. Here worker node 1, if I create a 10 worker nodes, this number of IPs 65,000 IPs will be shared by the individual nodes, means it's a node CIDR range, right. And also controllers is a star. So what is this controller star means, and star comma, and there are 2 other controllers are given, and you go to the Kubernetes documentation, right, and this controller manager and control F, right, these are the controllers. So a list of controller to enable. So here if you look at here, attach data controller to TTL after finished, all these controllers are included by default when you provision a new Kubernetes cluster. So here if you closely observe NodeIPAM, what is this controller will does is, means NodeIPAM is already included in the star already. So that's why I have mentioned in my documentation. So here NodeIPAM is basically whatever this CIDR range, which is 65,000 something, will be divided to the number of nodes you provision. Here number of nodes, how you provision a node here, when you register a node by using a kubeadm join, which is again in the same CKA, right. When you kubeadm join 10 nodes, you will be able to join. So whenever you join a node, what this NodeIPAM will does is, which will share this IP address and assign a some CIDR range to the respective node. Yes, so and that is available under the this particular specification. So how to prove that is, so I will just kubectl get nodes -o void, right. Now kubectl get node and say master node and -o, I wanted to output in JSON format, and jQuery single quote dot here spec dot CIDR range, SPEC spec dot podCIDR, PODCIDR, right. So this is a master node CIDR range is allotted, and if I run the same thing for my worker 1, right, I'm just changing worker 1, right. So 100.64.00/24 1.024, so means whatever the root CIDR range, right, which is this out of 65,000 is divided into the few here and few for here. If I create a worker node 2, again it will 2.0/24 until 65,000 get fills. So who did this all these things, which is by this controller, but correct how? If you look at this kubectl get pod -o void, so here Calico I have installed, right, that is a CNI which we have learned in the previous session. So kubectl get all, when I do all, right, Calico pods are available, and here Calico daemon set and Calico controller also there, right. And along with that, right, if you closely look at kubectl get CRDs, there are a custom resource definitions are installed by the Calico. These are the custom resources are created. So how to know that? kubectl API resources and grep for, right, and calico, right? So if you look at this particular calico namespace, right, there are the multiple CRDs are created here, right? So IPAM blocks, IPAM configuration, IPAM handle. So these IPAM configurations, right, say if I select the IPAM blocks, right, kubectl get IPAM blocks, so I have a 2 blocks are assigned, right? So where these IPAM blocks are came, so one IPAM block for master node, one IPAM block for my worker node. How to prove that? kubectl get pod, see my worker node 1, right, 100.64.235.129, which is in this particular CIDR range, this particular IP which will fits, right? So and if you look at the kubectl describe IPAM blocks and this 128, so not this, right? So when I do this, right, here kubectl describe this particular CRD of whatever the block which is created by the CNI, right? Here first of all /26, right? So you go here in the subnet calculator, /26 is nothing but 64 IP addresses, right? So out of the 64 IP addresses, it maintain the blocks of IP addresses, how many are unallocated and how many are allocated. So there are 2 IP addresses are allocated from this particular worker node 1 pool. So how to check that? Then you go and check here 100.64.219, this is the one. So these 2 IP addresses gone, and then rest of the IP addresses are available. That's what the it's maintaining inside, right? So now container networking and in a single node. So in the, this is a worker node where this bottom portion is the host network namespace, upper portion is a pod network namespace. So podCIDR range, yes, every node has a some CIDR range is assigned here. This is a some number, right, some CIDR range, and of course host network will have a ETH0 interface, and you have a 2 different containers in a same single node, right? It's possible, right? So kubectl run, right, you can write kubectl run nginx mod of the 2 replicas, right, something like that, maybe 2 different containers, right? So these containers will have individual IP addresses, right, and every container will have an interface ETH0, and by using a with pair, virtual ethernet pair which will be connected to the CNI bridge, CNI-O bridge, this bridge also will have a 1 IP address. So by using this bridge, it will connect to these 3 dots, nothing but a kube proxy, kube DNS, etc, etc. There are many more interfaces in between, and then the communication will happen internally within the one single node, right? So it's here the concept is CNI 0, this is a bridge, this will have one IP. And what about 2 different nodes, node 1, node 2, and these containers wanted to communicate? Same thing here, but the thing is whenever you install any of the CNI, that CNI come up with the VXLAN or IP in IP, which is one IP will embed in the IP, which is a networking concept. We need not to dig much, but the point is if this container wanted to talk to this one, then the traffic will go from a with pair CNI bridge, this will have a IP through the VXLAN, and through this ETH0 this will communicate, right? And there will be an overlay network also which will be used by the Calico. So that's how multi-container the communication will happen, this with pair. This is a very high level, and I am not a networking expert, but this is just to have an idea how the components are aligned. And this VXLAN IP in between also there are many more inside, that is purely we need not to know much, right? Now how pod gets IP address, this is the one of the main topic. So let's say this is a master node and this is a worker node, and master node will have of course a kube API server, and CNI plugin is installed, and in the worker node, yes, there will be host network namespace. By default it will be with the node, right? Then kube API server, say let's say kubectl run nginx pod -- image equal to nginx. That's what the command you issued, and which will goes to the kubelet. Kubelet will call a CRI plugin, which is container runtime interface. This plugin is nothing but the container D will use. This CRI plugin will use a container D and go, and it will immediately create a pod network, and just network namespace only it will create, just only C group and namespace. Next, CRI plugin will trigger a CNI, that CNI to establish a network between this pod network and as well as a host network. It will create this with pair, virtual Ethernet pair, attaching one end to the pod network namespace, other end to the host network namespace. Then also it will add a route to this host network namespace, that this host to know that there is a route is established, because I am creating a one pod. What if you 100 create 100 specific namespaces will be created, and this host will aware of it. That's how it works. So here in the pod network namespace this will be created. The next is this CNI plugin will have a CRDs like a bridge, IPAM, etc. So which are installed by default. So kubectl gets CRDs, right, -a, right? If you look at here, BGP, all are crd.project calico. So these are the, see, BGP periods, Felix, global, IPAM blocks, IPAM configuration, IP pools, IP reservations, control and network policy. So these are the custom resource definition which have some logic inside, right? I have made one video on CRD as well. So this, by using this CRDs from its pool, just now we have seen, it will pick one IP address and alert returns that IP address to this guy CRI plugin. Now what it will do is immediately, and by the way, before this one there will be an indexes IDs will be created here. Once the IP address is returned, right, and here CRI will go and create indexes, and its own pod specific namespace will be shared, right, and the sandbox container will be created at very first time. Sandbox container only will be created. Then after that, this kubelet here will instruct the CRI to pull actual image of the nginx, which is, if it is not there, it will pull from a registry. If it is there, it will go and create a container and it will attach to this particular namespace, right? Namespace in the sense this particular pod specific namespace which is shared here. So that's how, so means like here IP address is assigning to whom? This sandbox container. Sandbox container will be created by the CRI. CNI job is to take care of the network routes, etc. If you remove the pod, definitely obviously the same thing will happen. The CNI plugin will issue the delete route. So there are different routes will be added, so we need not to dig much. So that's how the very high level. If anybody networking experts, please feel free to add more information here. Thank you. Next, a POS container. So here we have seen a POS container. So what exactly this POS container? So POS container is nothing but it's a sandbox container. So we will call as a sandbox, right? POS is just a name. Maybe tomorrow somebody, some intelligent fellow will develop a even better than a POS Express also may come, right? So the concept is here is a sandbox container. That sandbox container created for every pod. In fact, before creating a pod, first sandbox container will be created. So what exactly this POS is, the sandbox? Sandbox will be inside the C group and a namespace. So here this blue color box consider as its own C group and namespace. And POS container will act as a parent container in the pod. Parent means we know only nginx pod, but its parent is this guy. This guy will take care of everything. Not nginx is. Nginx is just our application container, right? And So Linux namespace sharing, yes, correct. And this POS container will assume the role of a PID1. Again, what is this PID1? So sandbox container is okay. PID1 is nothing but it will take care of the init process. Not only init process, also it will reaps the zombie process, which means in case of any of the Linux process which say makes any of the inconsistency, then this sandbox container will take care of its application container to up and available always. Means like it will, like if it is become a orphans. So like here this is what the root namespace, and here that the parent pod network namespace. Under that there will be a POS container will be created, which is a sandbox by default, and this will have an IP address, yes, and a namespace will be shared. Here there will be a Nginx container will be created. This will act as a parent container, right? And this is a child container, and this will take a role of a PID1, which is init process. Somehow, because of the some zombie process within this particular Nginx container, say this container is a died. What happens is, since it's taken the assumed role of PID1 and init, so it will reaps and it does not make a orphans by its parent. And whenever this Nginx goes dies and comes up, IP address won't change. But if you kill this POS container, then this IP address will change to something else. So why the Kubernetes pod never goes die? Because of this POS container. The POS is a major backbone of the any of the pod, right? Now example of the POS container. So so there is a Nginx container, let's consider, and there is a hello world container. So what you do is, first you create Nginx container, just regular, and you create a hello world container, but add it as a child container. How to add? There is a big command line with complicated command where you can add it as a child, parent and child, yes, the CLI command. And so here Nginx is parent now, that's why the color is different, and it's parent for the child and responsible for if hello world dies, correct? But Nginx is not designed for such kind of a process, such kind of a work, right? So it does not take care of a zombies or does not run as a init, right? Because Nginx is a simple web server application, right? But here Nginx is what it's doing, it's taking care of a hello world, and we'll see the diagram. And here init process, each container will have an init process, must go through the init process, right? And also if container running another namespace, also init process is a compulsory. So PID namespace sharing by default is enabled, right? And PID namespace sharing is enables, basically it will send the signals between the containers in the same pod. So here if you look at the diagram, right, here this is the POS container, I just pause it aside, there is the Nginx container, and you made a parent container and made a hello world as a child container here, right? And this is sharing a namespace. Whenever this hello world is goes dies, then it will take care of this particular all the process, which is the same case as a POS will do. This just to know how the POS container will work. And by the way, if you wanted to know about the POS, this is the Ian Lewis, he created some nice article and explained this, right? Maybe you guys can go. And now the demo time. Demo point of view, I have a 2-node Kubernetes cluster as we have just seen, and I have nothing is running at the moment currently, right? So right, and I have installed a Calico by the way, and kubectl get all, and if you look at here get all, right, so it's a Calico is installed, and as well as the Calico controller, etc. Nothing is running at the moment, right? I am SSH inside the worker node 1, right? I will go inside the root user, right? Now so from the Kubernetes point of view, so as we know, kubelet configuration is located at var lib, right, and kubelet config. This is the what the kubelet configuration we know from the CKA, right, and this is the what the kubelet configuration. Now the second, containerd, right. So containerd configuration point of view, cat etc, right, and containerd and the config.toml file, and which is a very big. In the last session I have explained, right. So this is a root state and etc, right. This is the what the containerd plugin, right. Now, and the CNI. So CNI I have installed, and my CNI specific pod is running in the both the worker node 1 and as well as the master as well, both the is places this Calico is running, but the Calico configurations are located at cat etc CNI there 10-calico.conf list. So this is a Calico configuration, right. And if you look at here, the Calico logs are located here, right, and it's using IP address management by using this particular one, and policy Kubernetes etc, and its configuration is located in the same directory, right. So we are most interested in the CNI logs, right. So now I will clear here, right, cat. This is the CNI logs, nothing at the moment currently, because nothing is running in at the moment. So what I will do is, so this logs I will try to tail, right. So tail -f, right. Then now I'm trying to tail here, right, and I will just make a few enter here. Just remember this particular. Now I'll go to the pod here, kubectl run web1 pod I'm trying to run, and when I try to install, you see here there are a bunch of operations are append after this blank space, right. So these are the one, right. So these are the one. What I will do is I will just try to copy all the logs, right, and go to the my Visual Studio. There is a CNI log, just empty file I created. I'll just paste it here. Why I am looking here is I can see in a very nice and beautiful colorful way to word wrap here, right. Now, so if you look at the pod status, right, and pod might have done, right, kubectl get pod, right. So already web1 pod is running, and which is 100.64.235.131, and this IP address, how do I check that, and which is running in the worker node 1. So, and there is a command, right, which is taken from this particular CIDR range. This is a root CIDR range, of course, right. kubectl get describe IPAM blocks, right. So from this particular IPAM block, this is particular assigned, which is on worker node 1, right. So, and how many are allocated or how many available are here. So, right, these are the total number of 4 IPs are allocated, right. Now, so I will go back to the my CNI logs to understand what happened here, right. So Calico CNI found and extracted the identifier and Calico IPAM request count and automatically assign, which is by the CNI, right. Then after that it's, so sorry, after that if you look at here, there is automatic assign to the worker node 1, right, and it check for the any affinities, and right, then affinities and all these are the validations by the CNI. We need not to bother much. So, and what I'm trying to show here is, right, you scroll down here, populated the endpoint and IPAM, right, which we have seen, and when you scroll down here, so this is the last line, right, added a MAC interface name, active container, etc. So here you search for a container ID, right, from the beginning. There is a big container ID is given, right. This is the container ID, and say, let's say if I search for this container ID, right, so this is the what the container ID, and right, 75 ends with, and go to the console, right, and just search here. This is what the container ID, which is the last line. What is this container ID? In the previous sessions we have learned about the CTR, right. CTR-n Kubernetes.io namespace image ls there are various images, and right now container ls, these are the containers, and this container you see B8A start with the B8A FC and ends with the B175. So if I copy here, so in everywhere throughout the logs, right from the first step to right from the ending step, container id is referred as this container id, and its endpoint is assigned, and as well as a calico, this is the interface which is a bridge, and the web container and all. So this is we need not to dig completely, but we most bother about this container id, which is nothing but this one. So how to see that this is a POS 3.5 container, right? And how to check that? ctr-n in Kubernetes .io namespace and container info of this one, and just do the more, because it will be a more than a one page, right? So, and this is the what, this is the what, the sandbox container which we have seen in our previous slides, and its namespace is a default and pod name is a 1, right? And it's 3.5, that's what its container version, and it's given a snapshot and its extension, right? And if you dig more detail, it's a specs, its UIDs, and its respective capabilities and all, right? Permission and mounts, what are the mounts it has and all, right? And also if you look at the annotations, these are the annotations are here, right? And sandbox log directory. So as we know from the CKS, right? So pod specific logs are located in this particular directory, right? So if you look at here, cd var log pods, these are the pod specific logs are located. ls, so these are the specific logs, but our pod is a default namespace and web1 pod, so this is a folder. So cd, I will go inside this one. Now ls, there is a pod called a web1, so cd web1, right? And ls, so there is a 0.log, so cat 0.log, so this is a log file of the our nginx pod. And also another thing I wanted to show here is kubectl get pods, right? These are the all pods, right? Web pod. Let's take this web pod, kubectl describe pod so it's in a default namespace web pod, right? And when I did the kubectl describe web pod, you look at here CNI project calico, and there is a container id. What is this container id? You copy this, right, and go here, right? So now I will here, right? So what's the command? ctr command, right? We just put, right? So this is the what, the our container. So here this container is ends with the b75, which is nothing but which is a POS container. So which means the web1 pod will have an annotation is this, and POS container will have annotation of this, right? And its references are given here properly, and it's a SHA, etc. Last but not the least, so what if you ctr container.ls, say if I go and kill this particular container, but whereas nginx is there, this nginx is running, but if I kill this particular container, my pod IP address will change, because this is the what the it running in the under the root. So you can go inside this particular nginx container and grep for the process, etc. You will be able to understand the complete details. But this particular session is to just to understand how the things and IP address are related here, and where to check and its IPs and etc. right? And the CNI logs also, if you dig deeper, you will be able to understand. Yeah, that's it for this particular session point of view. Thank you all for listening, and let me know what you guys think. If I miss anything, please feel free to comment, and I hope you have learned something new. Thank you for listening. Thank you. Bye bye.